Hello, math magicians. Today we're going to continue talking about systems of linear equations. Sorry. And we're going to solve by graphing. So we're going to do the entire process. So the entire process is as simple as this. Go eat cookies. We're going to graph our equations. Then we're going to estimate the solution. And lastly, we're going to check. If our check ends up being false, we have to go back to estimate and then check again, and so forth. If the check turns out to be true, then the estimate is no longer an estimate, but a solution. So let's see here. To refresh ourselves, a system of linear equations is when you have more than one linear equation. So in this case, we have two, so this is a system. And graphically speaking, we're looking for where the two lines will intersect. When the two lines intersect, that point is my solution because it satisfies both equations. So the first thing we're going to look at is this problem. This problem here, the system, notice that both of these are slope-intercept form, and I abbreviate using like this, MINT, slope-intercept form. So because it's already in that form, let's use the key elements in here in order to graph it. So firstly, the slope here is -1. So the -1 of the first one. And then, of course, my y-intercept, my b, is +2. So I'm going to take that and graph over here. So to do that, we begin at +2. And remember what the slope means. It means either -1/1, or it means 1/-1. So this means down and right or up and left. Both of these are equally valid, so let me show you that. If I go down and right, it takes me to these points. But if I go up and left, it takes me to these points. Notice that they're all collinear, so we know it's still that either way is correct. All right, so we graph this, and I'm going to label this one right here. However we want to call this, I'm going to call it just its whole name, like that. Okay, next. To graph this guy here, we need to see what our slope is. Our slope there is +1, and our y-intercept we see is also +2. Now some of you might say, oh look, the intercepts are the same, which means they both touch the intercept at the same place, which means they intersect each other at that same place. So notice, start here and it goes up 1, right 1, or down 1, left 1. Because, just to refresh ourselves there, this can mean +1 over +1, or -1/-1. And then when I graph this, connect the dots, and we see what my intersection is. There it is. So I'm claiming that my intersection is 0, 2. Now we need to check that. So I'm just going to plug and play. So for the first one here, I get 2 is equal to, (-0 plus 2. And then, of course, 2 does equal 2, so it's a check. Continuing on, does 2 equal 0 plus 2? And of course, 2 equals 2. So my solution is no longer an estimate, but the actual thing. So 0, 2 is my solution to the system. All right, take a moment now to attack this one. Ready, set, go. And then, of course, the solution here is not 6, 4, but 4, 6. And the check would work out. All right, on the next problem here, what we notice is that we don't have these in slope-intercept form. Rather, both of these, I notice, are in standard form. Standard form. Now, recalling that standard form is helpful in graphing because what I can do is this. If I just cover up the y, in other words, substitute a 0, I get x equals -2. Or if I repeat that process by covering up the x, or deleting the x here, So notice in this case, deleting the x, my other equation is y equals negative 2. So now I have two intercepts, the x-intercept and the y-intercept. So I can actually graph that one fairly quickly. I'm going to make a change here on the graph to make it work. Note that I just shifted up the x-axis a little bit to make it fit better. All right, so negative 2 is here, and negative 2 is here. And let me graph that. And it's best, of course, to use a straight edge. I don't have a straight edge available on this device, so I'm just going to hand draw it like so. Okay, now the other one I notice is also in in standard form. So 2x equals negative 9, and negative 3y equals negative 9. Again, what did I do? I just covered this one up here, and there is one equation. And then I covered up this one here, and there's the other equation. So let me go ahead and finish that one up. This one here is negative 9 over 2, which since I'm going to use it on a graph, I'm going to estimate its solution, in this case, exactly equal to negative 4.5. And y is 3. So where do those live? Well, x is negative 4.5, lives right here. Again, just to check your scale, my scale here is this is negative 4, negative 5 is in the middle, so that's in a quarter. And the last one is y is positive 3. So y is positive 3 lives here. So now I need to connect the dots using a straight edge, and then I'm going to estimate my solution. My solution looks to be right here. So that here is a negative 3, and this one here is a positive 1. So I'm claiming that negative 3, positive 1 is my solution. So I need to test that point against both of them. Now, just to run through this real quick, substitute the negative 3 and the 1 here, and I do indeed get negative 2. Substitute the negative 3 and the positive 1 here, I get negative 6 minus 6, which does indeed equal negative 9. So no longer is 3, 1 an estimate, but 3, 1 is my solution. And excuse me, negative 3, 1. All right, your turn on this one. The hint I'll give you is use standard form for this one so that you have the x-intercept and the y-intercept here. But for this one right here, I suggest converting it to slope-intercept form. Why? Because both the x and the y-intercepts are going to be 0, which means I can't connect 2 points. I can only connect 1. So in this case, I would suggest converting it to y equals to see what you get. And now when we graph this and check, notice I end up with 3, negative 2.